Hello everyone, welcome to Step 5 421 class. This is the last week. I would like to thank you for your effort to follow these online classes. This week, we'll briefly study some popular unequal property cluster sampling design. Last week, we studied cluster sampling using simple random sampling in the first stage. However, if cluster sizes are unequal, we can use unequal property sampling design to improve the precision of survey estimate. Furthermore, by applying the second stage sampling, we can save cost further. We will consider only PPS with replacement as the stage 1 design. The PPS sampling has been studied in week 7 lecture as an element sampling, but we can use it in the cluster sampling too. We'll focus on PPS sampling for stage 1 sampling, but many other sampling property sampling designs are possible. In this class, we'll study two types of unequal property cluster sampling designs. The first one, called CSU unequal cluster unequal cluster sampling design. It's a one means a single stage. A single stage unequal property cluster sampling where the cluster are selected with PPS sampling with replacement using size measure equal to number of elements in cluster. So that is MI. The second type is the two-stage unequal property sampling. So the only difference is that we have a second stage sampling, which is a simple random sampling. All right. So we'll first study CSU1, single stage cluster sampling unequal property. Single stage, one stage. Okay. So because it's a single stage, all elements are observed. We'll now use PPS sampling to select clusters and apply the estimation formula for PPS sampling. So we let's first review PPS with replace sampling first, and then discuss how to apply it to the single stage cluster sampling designs. Okay, so recall that we first determine the size measure. So the size measure xi is believed to be proportional to yi. If you find good xi that more proportional to yi, then the PPS sampling is very efficient. So pi is essentially proportional to xi, but we normalize it so that the pi add up to 1, which becomes a probability. So for PPS with replace sampling, we apply use pi as a draw probability, right? So that is actually draw probability, and then select one element at random, and then with replacement means that we return the selected element to the population and do it again. So under this above PPS sampling, we obtain n observations of, so if you do it n times, right, n times, then we observe whatever element, so we observe yi and pi, and for if I is chosen. At k. Okay, so if unit I is selected at case draw, then we use these two observations to construct the ratio yi divided by pi and then call it p hat t hat k. Okay, so that is the estimator of total based on the case draw observation. And then we take the average, sample mean of them as an unbiased estimator. In the PPS sampling, we draw samples independently from the same population, and the with replacement sampling makes the resulting samples identically distributed. So we can view T1 to T hat n as an independent realization of a random variable whose distribution is this. Okay, so if you look at this one is actually yi divided by pi times pi, so which is yi, which is t, right? So the each one is unbiased, and we have n observations, so we just use a sample mean. And also because they are IID random sample, basically this is the sample variance of t hat 1 to t hat n, right? So we use sample variance of the t hat and then divided by n to get variance estimator. Okay.